Session 3.1 Measures of the Center. In these sessions, we'll be talking about the measure of central tendency, the mean, median, or the mode. We are analyzing central tendency of the populations or the sample. The two most widely used measure of the center of the data will be the mean and the median. Parameter. We talk about the parameter and the statistic from the chapter 1. So what is a parameter? A parameter is a descriptive measure of the population, and the statistic is talking about the measure of the sample. For the parameter, if we want to calculate the population mean, the notation of the population mean will be using this guy. We call this as the mu. And for the sample mean, we'll be using the X bar here. Let's look at the formula. The mean, or you can call this as the average, is obtained by taking the sum of all values in the data set and then divided by the total number of observations. For the population mean, we're going to use the mu to represent it. That will be equal to sum of all the values together and divided by number of the datas. Okay, and the capital letter of N represent the size of the populations. For the sample mean, we do have the same formula. We just use the different notation. So X bar will be represent the sample mean. And then sum of all the datas together divided by N. And the N here represent the size of the sample. I need you guys remember all the notation, okay? Population mean will be the mu. Capital letter of N represent the size of the population. X bar, that will be represent the sample mean. And then lowercase letter of N represent the size of the sample. And then you're gonna see this means the summation. Summation notation means you're gonna add up all the datas. Okay, now let's try to do the first example. The following data represent the travel times in minutes to work for all 7 employees of a startup web development company. So we do have the data in here. Compute the population mean of this data. Want the answer to the nearest hundreds. Okay, so population mean. Let's write down the formula. Okay, I need you guys write down the notation. And then you're gonna add up all the datas. So this is all my datas. And what is my n equal to? My n will be equal to 1, 2, 3, 4, 5, 6, 7. I do have a 7 data, so I'm gonna be divided by 7. Okay, use your calculator. You should get 174 divided by 7. And then that will be equal to 24.857. And then we need to want to the answer to the nearest hundreds. Okay, hundreds is gonna be here. So we're gonna add 1. So that will be 24.86. Make sure including your unit for the final answer. Okay, this is talking about the minutes. Okay, example 2. Still using the example 1, use your calculator to make a simple random sample of n equal to 3 employees. Compute the sample mean, obtain a second simple random sample of n equal to 3 employees. Again, compute the sample mean, want each answer to the nearest hundreds. State any observations you can see from the population mean and the two sample means. So I do have the same data here. And this is talking about the population. Now, we want to draw the sample from this population and then calculate the sample mean. Okay, so I already used my calculator to randomly pick 3 employees from here. So first one, the random sample got 23, 18, and 5. Now I want you guys find out the sample mean. Okay, so sample mean, they'll be using the X bar here. Add up all the datas, and we do have a 3 datas, so that's why we divided by 3. Okay, check your work. You're gonna get 6.57 minutes. Okay, make sure you're including your minutes on the test also. And then second one, I'm gonna do it one more time. I use my calculator, random pick the sample from here. This time, my sample data will be 36, 18, and 43. Okay, I want you guys to do the same thing. Find out the sample mean. Okay, add it up together, divided by 3. And this time, you should get 32.33 minutes. Okay, now I want you guys try to compare the sample mean 1 and the sample mean 2 with the population mean. For the population mean, we got it from the previous example. We got it like 24.86. However, the sample mean 1, we only got 6.57, which is significantly lower. But for the sample mean 2, we got 32.33. That would be a little bit higher than the population mean. Why would this happen? Because for the sample mean 1, we contain the smallest value in the data set, right? 5 and 18 will be the smallest data in here. And that's why we're gonna be pull the mean down here. But for the sample mean 2, the data will be including the largest value, which is gonna be 43 and 36. Which means that we're gonna pull the mean up. And that's why this number is a little bit higher than the population mean. So sample means are only estimate and can vary depending on which value are selected in the sample. Okay, example 3. Determine the median for the data in the example 1. So we do have the same data here. And how to find the median? Median means I want to find the middle data of the whole data set. So what we're gonna do, first, we try to sort the data. Okay, we're gonna write the smallest one first. So 5, 18, 23, 23, 26, and 36, and 43. After you sort the data, you only need to find the middle data. Okay, so think about it. I do have 3 datas on the left, 3 datas on the right. So 23, that will be in the middle. So the median, that will be equal to 23 minutes. Okay, example 4. Suppose in example 1, the startup company hires a new employee. The travel time of the new employee is 70 minutes. Determine the median of the new data set. Okay, so this time we're gonna add one more employee. And the travel time of this employee will be 70 minutes. Okay, 70, we're gonna put it in here. So I want to find the median again. First step, sort the data. And then we're gonna find out the middle data. But this time you could see I do have 3 data on the left, 3 data on the right. So in the middle data, that will be 23 and 26. When we have the two data, what we're gonna do? We will add it up and then divide it by 2. That will be equal to your median. So this time, that will be 24.5 minutes. Okay, so I want you guys pay attention for the example 3 and example 4. When you have the data set, that will be equal to the odd number. Okay, just like here, 3, 6, 7 data. So I'm gonna choose in the middle one. That will be the median. But when you have the data set, that is an even number, like the example 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we do have 8 data here. And then you're gonna be divided by 2, which is gonna be 4. And then we're gonna choose 2 positions, 4 and 5. So 4 and 5 here. And then we're gonna find the average of these 2 data. That would be your median. Okay, now I'm gonna teach you guys how to use your TI-84 calculator to find out the mean and the median. So first, on your calculator, you're gonna click on the stat. You could see you will have added number 1 added. Okay, so I could enter. So on my data list, I do have some old data here. So how can I clean it up? You could use the arrow button, go up, highlight the L1, and then click here, and then enter. So everything will be disappear. Okay, one more time. Use the arrow button, go up, highlight the L2, click clear, and then enter. Do the same thing, click clear, and then enter. So all the data will be disappear. So now I'll be using the L1 for my data here. So I'm gonna plug it in. I do have 23, 36, enter, 23, enter, 18, enter, 5, enter, 26, enter, 43, enter. Okay, you can see I do have 7 data here. Okay, so double check 7. Now I'm gonna click on the stat again. Go to the cal. On the top, go to the cal. I'm gonna choose number 1, one variable statistic. My data will be on L1. Okay, so did you guys see the blue letter here? Right? I'm gonna click second 1, which is gonna be represent L1. And then just go to the calculate. Enter. So you're gonna see my mean, sample mean will be 24.857. Okay, you could double check 24.86. Okay, or here 24.857. Okay, on your calculator, they didn't know you are calculating on the population mean or sample mean, so you may need to change the notation by yourself. Okay, they do have the same formula, they just have a different notation. So population mean will be 24.857. And then we're gonna go to the example 3. We're gonna go down here. You're gonna see the MED. This is talking about the median. Median will be 23. So 23 here. Okay. Now, let's try one more time for the example 4. We're gonna click on the stat. Number 1 added. This time, I'm gonna go to the L2. Okay, input this data. So 23, enter, 36, enter. Okay, the last one, that will be 70. Okay, so I do have X data. Good. Now, click on the stat. Go to the cal, use the arrow button to the right. Click on number 1, one variable statistic. And this time, I input my data on L2. So you can see the L2 here, right? So click on the second 2 for L2. Go to calculate. Enter. So you will see, let me go down, my median will be equal to 24.5. Okay? Okay, now let's try to do the next example. Example 5. The following data represent the travel times to work for all 7 employees of a startup web development company. We do have the data in here. Suppose a new employee is hired who has a 130 minutes commute. How does this impact the value of the mean and the median? Okay, so we want to compare the original data and with the new data with the 130 minutes, one more data here. Okay, so my original data, that will be this guy. And then we find out the mean from example 1, the median from the example 3 here. Okay, right? Now, I want you guys try use your calculator. Find out the new data set of the mean and the median. Okay, remember how to do it? Click on the stat. Click on number 1, added. This time, I'm going to go to the L3. Okay, so input the data. Remember one more, I do have a 130. Okay, add 130 in here. Okay, click on the stat. Click on the cal. Number 1. And then my data will be on L3. So I'm gonna click second 3 for L3. Go to calculate. Enter. So you should get the mean will be 38 and the median will be 24.5. Okay, 24.5 and the mean will be 38 here. Okay, now we're gonna compare of these two sets of the data. So first, let's compare about the mean. The original mean will be 24.86, but the new mean will be 38 in here. So we could see the mean increase significantly, right? That means the mean is really sensitive to the extreme values. Okay, we call this as extreme values because 130, this is the data is far away from the majority. Okay, 130 is somewhere like here. Far away from the majority, we call this is gonna be the outlier. Okay, when you add the outlier on the data, the mean will be adding differently. Okay, this shows that mean is sensitive to the extreme values. Now, let's compare about the median. Median is 23, but when you add one outlier here, it will become 24.5. It's about the same things in here. Okay, so we say the median changed slightly. Okay, from 23 to 24.5 only. So we could say the median is more resistant to outliers, making it a better measure of the center when data is skewed. So here, I just need you guys to remember it. When you add a data, when you add an outlier here, the mean will increase or decrease significantly. But for the median, it doesn't change even though you add the outlier on it. And we call the median is more resistant to outliers. Definition. Numerical summary of data is said to be resistant if extreme values, very large or very small, relative to the data do not affect its value substantially. Okay, this is talking about just like the median. Okay, it doesn't affect a lot. Okay, so one more time, median is more resistant to the outliers. And then mode. The third central tendency is called the mode. The most amazing thing is that the mode can be computed for either quantitative or qualitative data. The mode of a variable is the most frequent observation of the variable that occurs in the dataset. A set of the data can have no mole, 1 mole, or more than 1 mole. If no observation occurs more than once, we say the data have no mole. Okay, so easy to find the mole. Just find the most frequent data. Let's look at this example. What is the mole for the weight in pounds of the 10 students in the nutrition class? So mole means you want to find the most frequent data. So first, let's sort the data. Okay, write the smallest one first. There'll be 95, and then 117, and then 130, 133, 145, 154, 193, 210, and 268. Okay, sort the data. After you sort the data, it will be easy for you to find out the mole. Okay, you could see I do have a 2 data, that's a 117. So the mole will be equal to 117 pounds. Example 7. Using the sample data set of colors, find the mole color. Okay, so this is my data set. Blue, blue, green, red, red, blue, red, blue, green. So how can we find out the mole? First, I want you guys try to find out how many blue and the data's in here, how many green and how many red. So you're gonna count blue, 1, 2, 3, 4, 5. Right? I do have a 5 blue data. Count for the green, 1, 2, 3, 4. And then the red, 1, 2, 3, 4, 5. So 5 also. And we want to find the most frequent data. So you can see I do have a 5 blue and then 5 red. So we're gonna say the mole color will be red and blue. And we call this as the bimodal. Bimodal means 2 data values occur with the same greatest frequency. Okay, calculating the mean of a frequency table. Below are the data of 16 randomly select weights in pounds of models from a model agency. Find the sample mean. Okay, frequency table. So this means I do have a 4 data. There's a 85 here. And then I have a 2 data. That's a 98. That's a 1 data. It's going to be 100. Okay, and then we will present the data in the frequency table. So how can we find the sample mean? First, we're gonna do the weight times the frequency, just like the first one. 85 times 4, which is gonna be 340. Okay, I want you guys try to do the same thing. 98 times 2, which is gonna be 196. Okay, try fill in all of them and add it up all the total. What is the summation of this guy? And then add it up for the total, how many frequency in here? Try. Check your work. 100 times 1, 110 times 4. Okay, and then add it all up. They say they do have a 16 data, right? So when you add up all the frequency, it should be equal to 16. And then add up this column also. You should get 1,697. So how can we find the sample mean? Okay, we'll be using this formula. Sample mean will be summation of f times x divided by summation of f. Okay, so plug it in. Okay, you should get 106.06 pounds. Okay, make sure including the unit. Example 9. Total cost of the textbook for the term was collected from 36 students. We are given a sample of group data for the cost of the textbook. Find the sample, mean, and the median. Okay, for this time, we do have the range of the cost. And then they find out the midpoints for you guys already. Okay, and then frequency. So means like we do have 4 students buying the textbook is from $140 to $179. That's only one student buy the textbook is gonna be from 180 to 219. Okay, so how can we find the sample mean and the median? First, look at the formula. How you find the mean? We do have the summation f times y divided by summation of f here. So first, I want you guys add it up. What is the total number of the frequency? You could add it up together or check with this number. It's supposed to be equal to 36. Now, we're going to do it one by one. Midpoints times the frequency. Okay, do the same thing, 200 times 1, which is going to be equal to 200. Try to compute this part here. Okay, and then add it all up. Find out the summation of f times y. Okay, check your work. Add it all up, you should get this 10,960. Okay, and then plug in here. Use your calculator, you should get 304.44. Okay, so this is gonna be the sample mean. Okay, now let's try to find the median. We have one more column here. We need to find the cumulative frequency. Remember that median means I want to find out the data in the middle, right? So that's related to the cumulative frequency. So what is the cumulative frequency? We talked about it from the chapter 2 already, right? So we do have a 4 here. And then cumulative frequency, we're going to add up the new one. So 4 plus 1, you're going to get the 5. 5 plus 4, you're going to get the 9 here. Okay, keep going. 15 plus 10, 25. 25 plus 6, 31. 31 plus 2, 33. And then 36. Okay, make sure you remember the last one of the cumulative frequency will be equal to the sum of all frequency. Okay, now we're gonna follow the step here, how to find the median in the frequency table here. So we do have the formula L equal to 0.5 times N. And the L represent the locator, okay, the position of the data. N represent the total number of the data, which is going to be 36 in this example. If your L is a decimal value, then we're going to round it up. You always round it up to the whole number. And then use the data value in the round up L position. If your L is a whole number, then you're going to find the mean of the data values in the L and the L plus 1 position. Okay, let's try to do this example. L equal to 0.5 times 36. Because we do have a 36 data here. Use your calculator. That will be equal to 18. And 18, that will be the whole number, right? Whole number, we're going to follow this part. Find the mean of the data values in the L and the L plus 1 position. So I do have a 18, means I want to find the position of 18 and the 19. Median is the position of data 18 and the 19. So we're going to look at the cumulative frequency. Okay, so we're going to look at it 15. we can't choose the 15, right? Because the data is 18 and 19, greater than this guy. So next one, that'll be 25. So this is good, right? Because 25 is going to be greater than 18 and the 19. So we're going to choose this one. So the midpoints will be 320. So we're going to say the median will be lying in this class with the midpoint 320. Don't worry too much about this example because for this part, we will have a more example of the session 3.3. And also, I will teach you guys how to use your calculator to find out the mean and the median for the frequency distribution. So this is gonna be the procedure how you guys using your TI-84 calculator to finding the mean and the median. Okay, so for the example X, let's use the calculator together. Go to the stat, click on number 1, added. Okay, I'm gonna clean up the data for my L1 and the L2 and also the L3. I'm gonna plug in the prongs to the L1 here and the frequency will be on the L2. Okay, make sure they do have the same number of the datas. Okay, now I'm gonna click on the stat, go to the cal, click on number 1, one variable statistic. So my data set, this is talking about the data set is gonna be on the L1. So put on the list. List will be on the L1. Frequency, talking about here, that will be L2. So second to L2. And then go to calculate. Enter. So you could see my mean will be equal to 106.06. You can look at the median here also. That will be 110. Okay. Second one. Do the same thing. Go to the stat, click on number 1, added. And then this time, I'm gonna put the midpoints on the L1, frequency on the L2. Okay, midpoints L1, frequency on the L2. Go to the stat, go to the cal, click on number 1. Okay, midpoints is on L1 and then frequency will be on the L2. Go to calculate. So you can see my mean 304.44. Okay, match with this mean. And also go down, you could find your median. Median, that would be 320. Okay, so you guys can use the calculator to figure out the mean and the median for the frequency distribution. And follow this procedure. Skewness and the mean, median, and mode. We do have 4 types of the distributions. We have to remember that. We have the uniform distribution, the normal distribution. We call it like bell shape. And then skew to the right. Skew to the right means the right tail is longer. And then we have the skew to the left. Skew to the left means left tail is longer. So let's talk about these 4 types of distribution. First one, uniform distribution, is when each of the values tends to occur with the same frequency. You could see all the data, they do have the same frequency. Okay, we call this is gonna be the uniform distribution. Second one, we call this is the normal distribution. Normal distribution, because it looks like a bell, so we also call this is the bell-shaped distribution. And it means all the data is gonna be fall in the middle part here. Okay, and also this is gonna be symmetric. Like if we have this data set and we use this data to calculate the mean, median, and the mode, you're gonna find it out. The mean will be equal to the median, will be equal to the mode. That's talking about all these three guys will be located in the middle part here. Okay, that's the normal distribution. Number 3, skew-white distribution. And this distribution is not symmetric. And we're saying that skew to the white means the white tail is longer. If you use this data set to calculate the mode, median, and the mean, you're going to find it out. The mode will be the smallest number. And then that will be the median. And mean will be the largest numbers in this picture. Because the mode occurs at the highest point on the graph. So look at this graph. The highest point will be here, right? So pretty much the mode will be located in here. This is about like 7, okay? According to this picture, this is about like 7, okay? The mode will be the 7 here. And then for the median will split the data in the half. And because the white tail pulls some data to the white, so the medians must move slightly white to the mode, okay? Slightly white to the mode. So it's somewhere like here. That will be your median here. So the median is greater than the mode, but not by much. Last one, that will be the mean. Remember that mean is sensitive to the extreme values. In a white skew distribution, the long white tail includes a few very large numbers. Okay, we do have a few very large numbers in here. And this large number will pull the mean farther to the right. And therefore, the mean will become the large of the three values. Okay, so on the white skew distribution, mode will be the highest point here. Median will be a little bit higher than that. And then the mean, because it's sensitive to the extreme values, and these large values pull the mean farther to the right. So the mean will be the greatest number. Okay, last one, skew left distribution. And this distribution is not symmetric, and the tail is to the left is longer. Number 4, skew left distribution. This distribution is not symmetric, and then left tail is longer. When you use this data to calculate the mean, median, and the mode, you're gonna find it out. The mean will be the smallest one, and then the median, and then will be the mode. That will be opposite to the skew-white distribution. The mode will be located in the highest point, so pretty much the mode will be here. Okay, and then the median. Because the tail extends left, the median must shift a bit left compared to the mode. So the median will be a little bit less than the mode, somewhere like here. And again, mean is sensitive to the extreme values. And the left tail includes a few small numbers. And these low values pull the mean to the left more than the median. So the mean is somewhere like here. So you could find it out, mean will be the smallest number, and then median, and then the mode. Look at the example of these 4 types of distribution. Uniform distribution. Every value in a data set occurs roughly the same number of times. So the previous one, you could see this is the perfect uniform distribution. They do have all exactly the same frequency. Okay, this one is about the same, but we still consider this is going to be the uniform distribution. The example will be the histogram of rolling a fair 6-sided die. When you roll the die, when you get the number 1, 2, 3, 4, 5, or 6, they do have the same probability to land on each number. The distribution will be the uniform distribution. Second one, normal distribution, or the bell shape. The left and the right side roughly the same. Okay, and then the highest will be in the middle. The example will be the height of woman or height of the man. Okay. Number 3, skew to the left means the left tail is longer. Okay, example will be the histogram of age death from the natural cause. Okay, so you can look at the age. This is about from 10 years old to the 80 years old. And most people die at the older age, not the young age. So you could see more data will be on this side. Okay, so we do have the distribution skewed to the left. Last one, skew to the right. So white tail is longer. Example will be the histogram of hours of TV watched per week. So 1 week, how many hours do you guys watch to the television? Majority of the people will fall into 5 to 15 hours per week, right? Usually people watch the television, it won't be more than 20 hours. Okay, so majority of the data that will be on the left side here. So the distribution will be skewed to the right. What shape would you expect to see in a histogram of the following data set? Okay, we do have the GPA of core students, SAT score, last digit of social security numbers for random sample of students, and income of the USA residents. Okay, let's do it together. First one, GPA of college student. You can choose uniform distribution, normal distribution, skew to the left or skew to the right. So look at the pictures here. GPA. So usually we do have the GPA from 0 to 4, right? Some high school maybe they do have a 5 in here. But for the passing one, it has to be 2 or above. Okay, so I would say like the most majority is about like from the 3 and something like 2, and some people like get the 4 also. And not many students get the 1 GPA, right? Because they may kick out of the school already. So when you join all together, you could see that would be left tail is longer, so that will be skewed to the left. Okay, SAT score. So all the students will take the exam together. You could think about it is similar to the height of the man or height of the woman. That would be the normal distribution. Okay, some students do really good, very, very good here. But majority is gonna be in the middle. So that will be the normal distribution. Number 3, last digit of social security number for a random sample of students. So for the last digit of the social security number, so you could have a choice from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So you do have the choice from 0 to 9, and it will be random for the last digit of the social security numbers. So the graph, that will be looks like uniform distribution. Okay, all the number 0, 1, 2, 3 until 9, they do have the same chance to be the last digit of the social security number. So number 3, that will be the uniform distribution. Last one, income of the United States residents. So think about it. I would roughly put in the numbers here is about like 50,000, 100,000, 150,000 until 350,000. So usually people getting the salary will be about like here, right? Something like here. But some people like getting really, really high pay, maybe a daughter or some CEO, but not that much people is gonna be getting like 300K or 350K. So I would say like for the income for the United States, that will be skewed to the right, okay? Because white tail is longer. So the income of USA resident, I would say skew to the right because white tail is gonna be longer. Okay? Which measure of a sentence should I use? We learn how to calculate the mean, median, or the mode. And mean will be the most common measure of the center because we're gonna consider all the datas. However, the mean is affected by the extreme values. So if you have the data set, you do have the outlier, then the mean may not be the best measure of the center. Mean is used if you have a normally distribution because mean is the measure that includes all the values in the data set. So it depends on what kind of the data set do you have. If you have a normal distribution, then you want to use the mean as the measure of the center. But when you have the outliers, you may want to use the median because median is less affected by the outliers and the skewed data. So when you have the skew to the left or skew to the right distribution, or you do have the outliers, really extreme numbers, you may want to use the median for the measure of the center. For the mode, we always use for the categorical data. But other than that, we may not use it often. That's it.